that's true. Yeah, everything's good. Can you say something quickly? Just see if we.
Hello.
Yes,
Hi.
it's good. We're good. Everything's good. So today we're going to be doing strings, 2D arrays, dynamically allocated 2D arrays. We're going to be doing structs. We're going to be doing linked lists, and we're going to be doing command stuff. So quite a bit to do. So let's get into it, I guess. Let's get going. I will just finish putting everything together here. Here's Genie. And so I'm going to have my notes open. So if you want to make reference to that, then you can go there. I guess I'll put the link in homework help just in case people want to go there. So www. There you go. So you can go to that link in homework help if you want to see my notes, which is what I'm going to be making reference to as we're going through this. So yeah. Okay. Let's switch the cameras to here. There we go. And did I put the right number? Is this CPS session 4? I think it is session 4. Yeah, that's fine. Okay. So let's start today. I mean, is there any questions before I start what I'm doing here? Okay. Sounds like that's. Oh, yeah. Question or no? Okay. I thought someone unmuted there, but okay. Sounds good. Okay, so we're going to start with a string for today. Like, that's what we're starting today. So a string is essentially a array of characters. So if I say the word, like if I say this, I say hello. This is equivalent to saying like that's equivalent to saying an array that's H, E. I think you can imagine where this is going. L. I'm not going to type everyone. There you go. ... So it's equivalent to an array like that. So how do we actually deal with strings like that? So it's essentially we have the characters here, and the last character is the null character. So it looks like that. And so a string in general, I guess I may as well write everything out for this one example here. So almost at the end. So these two things are essentially equivalent right here. An array with these values in it, or I guess that's not really the best way to write. This looks like an index, but a string like this. So notice the double quotation marks here and the single quotation marks here. So the single quotation marks are for a character, and the double quotation marks denote a string. Just trying to think of like what details could I say about strings here? I'm not going to talk about the multiple dimensional ones. Okay, so like if we want to fill a string, so if I want to print a string out, so I'll say printf here. It'll say, please enter a string. Then, and I say scanf. How do I fill a string into a variable? Well, I already told you that a string is a string is a array. So whatever I assign this to is going to have to be an array, right? And so and it's not only an array of numbers, but it's a character array. So I'm going to call it char, and I'll call it string name, and it's an array of characters. So when I assign this scanf, it's going to go into string name, or string name like that. Right. So if I say and I'm going to be taking in a string. So there's a special placeholder version for this. And let's see what happens when I print this. So we're going to see there's going to be a slight problem that happens when I do this, and we'll see why.
Adam, you need a pointer on the string name, I'm pretty sure. The ampersand for the scanf.
You don't actually need it for this one. So for this one, you actually, on purpose, I should have mentioned that actually. But yeah, you don't need the ampersand because you need the ampersand otherwise because you're saying I want the address of this variable, and that's what I want to assign there. But string name is already the address of this.
Okay.
So for this particular case, you don't need to put the ampersand. I think it makes no difference, but yeah. Go for it, yeah.
So is there anything like what's the, like from a kind of comparison, I guess, perspective, what's the difference between the strings in a printf statement and the strings like in a variable? Like, are they any different, or are they just one variable?
Yeah,
then?
like you thinking like this? Like if I write this and I
Yeah,
write
like,
the string between quotation marks?
Yeah, what are those? Are those like strings? What are those from a...
These are strings too. I mean, I'm pretty sure printf is a function that takes in one variable, and the one variable is a array of a string, like a array of characters, and that's the variable it takes in.
So those are essentially strings too. It's just that
These
with
are
these
also
ones.
strings. Yeah, these are also strings. Yeah.
So with these ones, you just don't print them out, or like you just like print them out. Like it's very straightforward because you just print them out. But they're essentially the same thing as the other ones. And these ones, so this one will be an array too. All of these.
Yeah, all of these. This one I'm typing right here would also be an array. Yeah.
Okay, thank you.
Right. No problem. So I'm pretty sure if I do this and then I say just string name, I'm pretty sure this will work how I'm expecting it to not work, if that makes any sense. Because there is an issue here. Compilation failed. Error array missing. Size missing. Oh yeah, I have to put a maximum size on it. I forgot about that. So like maximum size, I'll just put like 25 characters there. Forgot. You have to define the length of the array there. Okay, so if I enter a string like hello, it's gonna print out the string that I said with an added space in front of it because I put a space here. So let me get rid of that space. So if I say hello, it's gonna print out hello. Okay, but now what if I type in hello, wow. It just types hello. So this is the problem with scanf. The problem is that scanf thinks that the space is the end of the string, and so it stops reading after the space. So we have a different function that we use for this. So this works for one character. It works for one word. It works for one word, but it doesn't work for an entire sentence. So we have a new function that we use, which is fgets, right? And so in general, that's f. You use it like this: fgets. The string that you're going to put everything into, so string name, a maximum size, 25. And remember, it's a maximum size, so it doesn't have to be that size. And you do std in, which is standard input. So that just means you're going to do it with the keyboard. You are also semicolon. You are also able to put input file here. Input file here. No, hold on, that doesn't make sense. What? Did I make a mistake in my notes here? Let me check quickly the actual lecture slides on this. That doesn't seem right for file. Give me 1 second to check this.
I thought for file is just in. Like
yep,
if you name the file, like you do file and then asterisk in, and then you do the name of the string, the size of the string, and then just in.
That makes sense to me. Yeah, I think when I wrote this in my
I
notes, I meant like
thing,
this is the name. This is the name of the file that you're inputting.
Yeah, I think it's just the same like fscanf or fprintf where you just do in.
Mm-hmm.
But this one includes like more. It includes the size of the string.
Yeah, exactly. So yeah, so there we go. That's everything. So I'll just stick with stdin, right? So that means it's the standard input. And so now this is a new function. If I restart this and I say, well, let's start with hello. Does hello work? Hello works. Okay. Then let's do hello wow. Hello wow. Hello wow also works. So fgets is essentially the same thing as scanf. It's just that it doesn't count. It counts enter, like the next line, as the end of the string, not space. So scanf counts space as the end of the string. So that's the problem there. So we use fgets in general here when we're trying to get a string that's a little bit longer. Okay. That is fgets. We have a few extra. Yeah, we have a few extra details here that we have to go over. Yeah, question.
So when you use fget, what happens if you don't know the length of the string, or is like let's say you don't know the length of the string and it's not from a file? Like what do you put for the second two parameters?
Like this one here.
Like go up. See fget. Like if let's say you don't know the length and you don't know the second parameter, like the third one, like the file. There's no file it comes from. Like what do you put there?
Well, you'd have to like. Do you mean like you don't know the name of the file that it's coming from, or?
Yeah.
Well, yeah, remember how here you say like file star in, and that's like I think that's how you do it. I forget how you do it. But you declare. Let me just find the actual code for getting a file. Yeah, so this is like declaring in as a variable that holds the name, or that like points to a file, right? And that's what I would put here, in.
So it's like a default thing that you put if you don't know.
The default thing that you put, like, you'll definitely know if you're getting from a file or getting from the user, right? So if you're getting from the user, you do stdin.
stdin. If it's not a file, it's just the file's name.
You just do the actual file's name. Yeah, you just say in or whatever.
So and it can be anything else, just either file name or stdin.
Yeah.
And what happens if you don't know the strings name? Like, what happens if it's declared but it is not nothing in the brackets?
You have to put something in the brackets here.
Or can't you like put nothing in the brackets and then like depending on how big the string is, that's how big the array becomes?
No,
Can't
no.
you do
That would be kind of like dynamically allocating it, kind of. So like see here, if I don't put the length of the string here, it just says missing array size missing in string name. So you have to put name, but this is generally the maximum length of the string. This isn't the entire string, right?
Yeah, because
the string doesn't have to be 25 characters long.
Yeah, because you can do like you can make it like bigger, so like it fits more every scenario kind of, and then only use like half of it or something.
Yeah, and essentially that would be like dynamically allocating what's going on here, right? You'd have to have a dynamically allocated array, which is what we talked about last time.
All right. Okay. Thank you.
Right. So there's a couple extra functions here for strings. So we need to use hash include string.h. And so this gives us a couple extra functions. So first I'm going to just erase this. We don't need this. I'm not actually using a file here. I think if I compile this, it'll work. Okay. So the functions that we got, I'm going to declare another character string. So character string 2. I'll also make it 25. And I'll say character string 3. I'll also make that, don't put a space, do I? I guess it doesn't matter, but 25. So now I have 3 strings. So one is string name. I guess I could have just called this string 1, but whatever. You know what, I will just call this string 1, just to avoid any confusion. So what we're going to do now is we're going to use the 2 extra functions we just gained by using hash include string.h. And those 2 functions are strcpy, which is a function that takes in 2 strings. So let's say I'm going to take in string 2 and string 1. And what it's going to do is now if I print f, so if I print out string 2 is %s, and it'll be string 2. And I'll do it before here too. If I say, you know what, here I'll say, please enter a string for string 1, and I'll do the exact same thing, but just for string 2. Please enter a string for string 2. Put a new line here. So now if I run this, and if I just quickly here say, this string 2 before is string 2 after is. If I run this, we have a problem. String 3 is not used, so never mind. That's the only problem. So please enter a string for string 1. I'll say hello, wow, whatever. Wow, hello. So the string you typed is wow, hello. Or hello, wow, I mean, sorry, is the first one there. String 2 before, so look here, string 2 before is what I said for string 2, wow, hello. And then afterwards, string 2 is now what string 1 was. So we can see that what's happening is strcpy is string copy. It copies the value of string 1 into string 2, assuming that there's enough space. So if I set string 2 to be just, I don't know, 2 characters long, 3 characters long, and I do this, right? String 1 is going to say hello, wow. I keep doing the same typo. Hello, wow. And for string 1, I only have 2 characters, so I'll say like, hi. So you see, string 2 before is hi, string 2 after is nothing, because I'm trying to copy something of length 20, well, length, whatever the length of hello, wow is, right, into string 2. And string 2 only has a max length of 3, and so an important detail I guess I'll mention now is that it has a length of 3. That means it can hold 2 characters though, because the final character has to be the null character. You have to have one of the null characters. So if you have a string of length 25, it can hold maximum 24 characters. Okay, again listed from 0 to 24, and the 25th character is gonna, well, the 24th character really is gonna be the null character, right? The last.
Okay.
Sorry,
Yes.
go ahead.
Okay, so like, does the counting start at like 1 for strings?
No, it starts at 0.
So then hi, wouldn't that be like if you Okay, I'm a bit confused with the counting. It's like, because when you hold like 3 things inside of it, can't you hold like?
So like here, let's look at string 2. String 2 right now, after the here I'll do it in a comment. So string 2, what does it have in it? First character is H, then I, and then it's the null character.
That means there's one more space left over.
Well, this is going to be index 0, index 1, index 2. So that's 3. There's 3 things in there. So that works. This is full. This is full.
Ah, because like when you declare it, that's the size, but when you use it, it's the index. So this,
yeah,
right?
But this is still the number of things in there. It's just that index starts at 0. So this is the second index, but it's like the third item we have. It's the second index though. Index of 0, 1, 2.
So whenever you're declaring any array, like if it's like, let's say in something array 5, 5 is the number of things inside of it.
That's right.
And then when you actually use it, you don't use the size of the index, so it's like 5, 10, 1, 0, whatever.
Exactly. So if I want to get, like if I have an array here, I say like array 5, and I want to access the last item in the array here. You know what? I'll just even do it in general. Array size. It's some size. If I want to access the last item in the array, I'm going to do array size minus 1. Because I want to get, I want to access the index, not of, like, let's say a size was 5. I don't want to access array of 5. There's nothing at array of 5. I want to access array of 4, which is the last entry.
Okay.
This is to get the final thing.
Okay, and you always, it's always indexed unless it's like declared. Unless you're declaring, it's always an index, wherever it's in the brackets. Right?
Yeah. Like when I'm declaring it, I'm setting a size, but when I'm using it, it's the index. It's the index.
No, but like when you declaring it, that's the only time when it's a size. Every other time.
Yeah. Every other time you're just specifying the index you want to access.
All right, thank you, Adam. I really appreciate that.
No problem. Yeah.
Adam.
Yes.
So we had a question in the study hall for CPS that like I was a bit confused by. So the question was, and they gave like, let's say char string 3 of size 25, and the question was, how many chars can you hold within this array?
Mm-hmm.
So I said 25, but the answer would have been 24 because they said, well, the last one is going to be the \0, you know, the null, like the final. But technically, can't you store 25 chars within a char array? It's just not viewed as a string.
Yeah. What was the exact question? What was the word of the question?
I don't have it off the top of my head, but it was along those lines, and they didn't mention anything about strings. They just said, how many chars can you hold in this array? I remember that.
Yeah.
If you said that the variable was named string, though.
No, it wasn't. I'm just looking at this screen and trying to figure it out. It may have been. I don't know.
Oh, okay.
If they didn't say, like, if the question was how many characters long can a string contained within this array be, that's the answer. The answer is 24. But if it was just how many characters can be stored in this array, that's 25.
Okay.
Right? That's 25.
I have a question. So oh, sorry, were you?
Go for it. Yeah, go for it.
So you said that because when you executed this, for the string afterwards, or string 2 after the function gave you nothing. I'm still confused on that because wouldn't it at least give you the two, the first 2 characters? Because you said that the null, because it carries 3 characters and null included. So if you like, I don't understand why it's
you're trying to say like it should return HE at least, right? HE.
Yeah, at least. Yeah.
Yeah. I agree. That seems like that was what would happen, but pretty much all I can say is I guess it just means that the function will try. If it can't, it'll just not do anything. It'll just. This is, I guess, an error that I'm getting here, and so it's sort of like it's like behavior that the way the computer is acting because there's an error happening since this array is smaller than the necessary amount for this function. So. The function, that's probably just a property of the function, is that just like the function decides that if it's not able to do what it's trying to do, it'll just not, like string 2 will just go to blank. And so that seems like
that's what strcpy does.
That's what strcpy does, is if it can't do what it's trying to do, it'll just set the string 2, the thing you're trying to copy into, to blank.
Mm-hmm. Yeah. Like the actual answer should be HE.
Because I guess so. If you were to think, but that would, I guess, be a different function, right? It would have a different property. It would like make a different decision
Okay.
if it was, you know, right? So, but strcpy does this.
Okay.
It runs into error.
Thank you.
Yeah, no problem.
Adam, is there such a thing as a like an array but of like characters, not like a string, just like an array of characters, or is it nothing?
Yeah.
They are the same thing.
They are the same thing. A string is an array of characters.
But could you have like not because like isn't string used for like words? So let's say if you want to store a bunch of colors, you want to store red or like R, Y, B. Can you do that? Or
Yeah. Just the same as you do a string, an array of integers. It's just that each character is you just use single quotes to assign strings, and yeah, that would work the same.
So they're the same thing.
Yeah, they're the same thing. Okay, I'm gonna move on now because we got a lot of stuff to get to. So I'm gonna move on to str length, and then that's everything for strings because we do have to talk about our arrays, and we got a lot of stuff to do today. So if anybody has a quick question about this, then I'll do it.
I have a question. So if you use the function strlen for, let's say, string 1, how many characters would it say it has?
Well, let's just try it right now. Let's see what happens. So I'm gonna say printf. So we're gonna talk about the next function that we have here, which is str length. And this was we're talking about strcpy. So str length is gonna say, okay, well the length of string 1 is. I'm gonna set this back to 25, just so we have more things. The length of string 1 is %d, so it's an integer, but it's a counting number, and it's going to be str length of string. Oh my god, string 1. I can't type. And then for string 2, it's just going to be string 2, and let's just see what it returns to us. So compile. We have a problem. No, don't have a problem. It's just string 3 is the problem that they're saying. Let's see what's happening here though. So %d expects a format of int, but argument 2 has type size t, aka long unsigned int. I think it won't break though. Let's just see what happens. So I'll say hello. Wow, this is nice. So yeah, there we go. So the length of string 1 is 10. So 1, 2, 3, 4, 5, 6, 7, 8, 9. And then, oh, I'm surprised it doesn't. I thought str length doesn't include the null character. Oh, I think
it's not supposed to. I asked during the final exam one. They said it doesn't include it.
String length 1, 2, 3, 4, 5, 6, 7, 8, 9. And then let's see for string 2. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Oh, but the length of string 2 is also 10. It's also 10. Hold on. Oh, because, well, actually that makes sense because of this line of code that I'm running right here. So I'm gonna just erase that, and there, I'll erase that, and I'll just put a new line here, and I'll put a new line here so we can read it, and I'll also just comment this one out because it stops giving us an error. So let's try this. Let's see what's happening here. So if I say try again, I'll say hello. Wow, this is nice. So yeah, it is working now. So what I typed string 1 is hello, wow, and then it's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So it's giving me 13. I'm surprised. I thought I was quite certain that string length doesn't count the null character. So even though we have 12 characters here, what's happening is that it's counting the null character as part of the string. But in my notes, and I remember the professor saying that it doesn't count the null character. So let's try to see.
Adam, did you accidentally press space after you entered those things?
Okay, let's see if I did that. Yeah, let's take a look. I will make sure I don't. Hello. Wow. Oh, yes, quite possibly. This is nice. No, still doing it. I did not hit space those 2 times. So, yeah.
Is it counting your new line as a character?
And spaces aren't considered a character anyways, right?
Like when you hit enter.
Spaces are considered as part of the string. Spaces
No. When you hit enter, it enters
Also,
a new line into
spaces,
the console.
it's going to increase the length by 5.
If you hit space, then if you hit space 5 times, it'll be increase the length by 5. Yeah. And enter. Yeah. Someone was saying enter there. Yeah.
If you try,
maybe try predefining instead of. Sorry. Maybe try predefining instead of taking input.
That's what I was gonna say.
Okay. Let's try that. So
maybe
instead of please enter, I'll just say string 1. No, string 1. Wait, do I just say string 1?
I
pretty sure you need to.
I think I just
Adam.
equals. Yeah.
I looked at the lecture and he says strlen returns the length of the string, not counting the null character.
Yeah, that's what I have too here, right? And so I'd be
Wait, you're
surprised-
using fgets, right?
Yeah.
Fgets count the new line as part of the string. It's the
counts
same
as
problem
part
that we
of
had in Lab 9 for one of the questions.
Yeah, I see. Okay. Let me try this one here. Let me see. I'm just gonna define it here. I'll say hello, wow, and pretty sure this will work. This is nice. And then let's try that. It did compile. Did it build? Yeah. So yeah, now it does what we want. Okay, so the problem that's happening, yeah, you're right, is that fgets is counting enter as a character, so it's adding one extra length to the string. So this is what's happening here. So fgets is going to add an extra number. How do you counteract that? I'm not really sure. You just have to remember, I guess, keep track of where you use fgets. But yeah, fgets, when you hit enter with it, and there's no other way to input the thing. So definitely fgets is going to do that. Here, I'll get rid of this new line here. But yeah.
I mean,
it.
in like a technical term,
Mhm.
it reads the buffer. So when you hit enter, the enter character goes into the buffer, but fgets can still read it.
Yeah. Yeah. Exactly.
So the maximum number of characters you can input is 24, right?
Yeah, let's try that. Let's try something that has 24 characters. Oops, I meant to put this here.
What does it do if
Yeah, question?
I was gonna ask, what does it do if it has more than 24 characters?
So let's try it. So hello wow is that's 9 characters. Is that what we said? 4 plus 3 plus okay, and then a null character. So oh my god, this is gonna be very. How do I? 1, 2. Wait, it was already 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 16, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 24. Okay. Some reason hard to count and type random numbers at the same time. So there we go. That is what I typed. It has a length of 24, so it works. And let's try add one more character. Oh, it did compile successfully. Oh, and it added the extra one. Length of string is 25. Doesn't have.
It will
null...
print the string, but you're overwriting data. Like
Yeah.
the next address spot over, you're overwriting whatever's stored there.
I'm gonna add another one and see what happens. So it doesn't do the next one. It doesn't do the next one. So it has no null character. That's the thing here. It has no null character. So I'm quite certain if I try to print this now, we're gonna have a problem. If I try to print this, string 1 is.
Question. So this is printing the string length is counting the spaces as well, right?
Yeah, it is. It is. Yeah.
Okay.
Oh no, I'm printing it. And never mind. What am I talking about? We printed it, and we have it right here. Oh, it failed to compile. Why did it fail to compile now? Oh, it's too long. So now it tells me it's too long. And still too long. If I remove it one more time. That's strange. Oh, it's compiling, but it's not building. Why is it not building?
Maybe your like command window's on.
Yeah, possibly. That's what it is. Okay, good. So yeah, let's try that again then. I'll put it should be back. So if I try to compile this and build it, it builds. That's fine. It includes the H but not the B. And if I try to print it, it still prints. I'm kind of surprised that it does that. But I guess why not? So then, just thinking, why is the null character necessary then if it still understands when the end of the string is, even if I override the null character? So what's happening here is that this is 25 characters in here, right? So it doesn't. This string doesn't have the null at the end. If I try to add another one, it just doesn't include the next one, so it's past the maximum length. But here is no different. I mean, we just have the null character on this one, right? So we do have the null character. If I try to print what, if I just say printf, this should be the null, and I say %c, pretty sure that's character, right? Yeah, and then I say string 1 of 24, index 24. Yeah, nothing exists there. This should be the null. Okay, it just doesn't print anything. What if I do 23?
Well, because the null character is actually two separate characters, I don't think it will point anything.
Yeah,
Or
that's
print
kind of
anything.
what I was thinking. Yeah, so I guess it won't print it. I guess it's null, so I guess it doesn't have anything there. But when you manually write it, it's this symbol.
I have a question.
Yeah.
Yeah, and it's about fgets and scanf. I think we can use the scanf with the apostrophe, not the apostrophe, the I forget name, like between the comma up there, and it will still read it like even though it like with spaces. Like if you write it.
How?
And
How do you
then-
write it? Like, so if I go here and type scanf here.
Yeah,
what should I write inside here?
Like
Then-
when the program starts, you can use the I forgot the name.
Take your time. It's okay. Yeah.
The thing that makes this orange.
The string, like the
No, the one that you're not
the
the
quotation
one.
marks.
Yeah, the quotation marks there.
Yeah.
If you run the program and then you type and then you put everything in quotation mark, it will still.
I
with
see.
the-
Okay, I see. So if I say string, I can't type today. String 1. Okay, string 1 here. And I say compile, build, there you go. And I say hello, wow. Then the string you typed is, it's still just hello. It still says space there.
Oh, okay. And
See?
what if we try just one instead of double quotation marks? Try one because I read that somewhere.
Still doesn't like it. Space is still the thing that stops it there.
Okay.
Yeah. So.
Thank you.
Yeah, but good to try it. Okay, any more questions about strings? That's essentially the end of strings. Otherwise, we're gonna move on to 2D arrays.
I just have one question.
Sure.
So let's say we have a strings of letters, okay, like whatever the letter is. If you want to save it in one, like, do you know how each letter in the strings has its own position?
Yeah.
Its own location, sorry, not position, location.
Index. Like it has its own index, right?
Yeah. I was like, try to do it in like when I was studying. To save it in to save all the things. Like let's say we have a string of hello HELLO, and I wanted to save it in one other variable, just one of them. Like to save all the letters in that string in one variable instead of having different location all in one location.
Yeah, so you're trying to say like you just have a variable called like name, and it just is the string that is the name, right? But the thing is that a string is an array. So you can't have one variable that holds all the characters. A string is an array. There's no difference there. It's just an array of characters. And so
I thought we can dynamically like use the malloc or calloc. I asked one of the guys in the beginning. That was my question. Yeah, I thought we can use malloc and calloc to save all the letters in one variable, but
in one array. You can save it all in one, and that's what we're doing here. So like all these letters are saved into string 2. String 2. Right? String 2 is an array of length 25, but that's okay. All these letters here are saved into one variable string 2. So if I try to print string 2, see if I print string 2 here, it'll here I'll put print here, I guess. It'll print all the characters that I have there, which is essentially what you're saying, right? So hello. Okay, I guess I didn't do there. This is nice. It's right there. So that's essentially it. You can't get more condensed than that because this has to be an array. So this is the simplest way you can have it in C.
Okay, I see.
Good?
Okay, it's impossible to have it in a non-array.
Yeah, because it is an array. It's like saying I wanna write this matrix as just one number, right? You could like take the determinant, but that wouldn't be the same thing as the matrix, right? That wouldn't be the same thing as like what we started with, right? So yeah. Okay, so the topic. I can't type today. The topic for here is going to be 2D arrays. Okay, so 2D arrays is just a matrix. That's what it is. So if I have a int, which is matrix, to define the 2D array, I put 2 square brackets, and if it's like a I don't know, 5 by 3 matrix, then it's a 5 by 3 matrix. There we go. Then to put in all the information we want, or to access all the information we want, we're going to have 2 for loops for this. So what I'm going to do is, like, let's say I want to fill this with some numbers. So for int I equals 0, I is less than 5. So this is going to go through, the idea here is that we're going to go through all the rows and then through all the columns of each row. So this is saying for each row, I plus plus. So hopefully this makes sense to mean for each row. Okay, maybe, yeah, okay. For each row, do another for loop. Int j equals 0. J is less than 3. J plus plus. So this is saying for each column, or for each entry in each row, is a way to think about it, right? For each entry in each row, do something, right? So I'll say matrix of I j equals some whatever, 2 times I plus 5 times j, whatever. There you go. That's what I'll do. That's what it's gonna be. And then if I try to print this, so this is gonna be now print the array, and this is to fill the array. So if I try to print the array, it's gonna also be another for loop. You can do this in the same for loop, but I'm gonna do it separately just so you can see, right? And yeah, let's just give it a try. So I'm gonna be printing the ijth entry of matrix. So it's gonna be a printf statement. So think about it for a second. I'm gonna start at 0, 0, and then the next entry I'm gonna have is 0, 1, right? 0, 1, 0, 2, 0, 3. So I'm kind of going along the top of the matrix. If you think about that for a second. Remember, normally when we talk about matrices, 1, 1 is the first entry, but here in a 2D array, 0, 0 is the first entry. So printf percent is probably an ls. I guess this probably. Oh no, there's no division. It's just integers, so it's fine. It will be a decimal. And it's going to be matrix I j, and put a space. Let's see what happens. 2D array. Study hall. Save. Build. Good. There we go. So this is our array. It's a 5 by 3 array, so we have to go 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3. There's 5 of them. I guess what we could do is I could just say printf. Oh, no slash. I don't know why I put a slash there. Printf. Just put a new line. So if I compile this, there we go. There is our 5 by 3 matrix. We have it. So that's for printing it. The new line there is just saying after I do the 3 entries of each row, put a new line. Right? After I insert the 3 entries for each row, put a new line. And I get this.
You say you can do the thing in an array, right?
One more time, what'd you say?
You can do the same. You can do everything in the one array. I mean one loop.
Yeah, I could do everything in one loop. Yes, I could do everything in one loop. Yeah, I just did it separately so you can see, like, this is filling an array and this is printing an array, but I could just put this in there and print f there, and it would be one array.
So what would you do? Would you just do a print f after matrix ij, and then another print f? So we should do that and that after.
Yeah, and then that's one. Now it's in one array there, like that. It would do the same. Okay, so I'll just erase that though because I think I'll leave it separate. Just I think it's a little bit more illustrative. Yeah. Okay. So any questions about this? I know I'm moving a little fast, but we just got a lot of stuff to finish. So
that makes sense.
I will move on to dynamic allocation of 2D arrays, which is next. Okay, so unless anybody has any questions right now about just these non-dynamically allocated 2D arrays.
The real big move is you just create 11 different integers. 15 different integers. That's the real big.
Yeah, and just keep track like that. Yeah, that's the real way of doing 2D array. So,
yeah, it's real.
Yeah, let's take a look here about how to do dynamically allocated ones. Now, there's 2 ways to do dynamically allocated arrays, 2D arrays. So int main here. So the first way is called the software engineer's method. So we'll go here. So I'll say topic for this one is the software engineers method. And so what we want here is we want to have a 2D array that is, we don't know, like the point of dynamic allocation is that we don't know the size of it when we're running it. So the first method is essentially this. If you were to take some array like this, one right here, this 2D array, and you wanted to describe that number 9 there. If you wanted to describe the number 9. Well, there's a few ways you could do it. Remember, we're talking about an array, so the 0, 0 entry is that 0 at the top left corner. So there's a few ways you could do it. You could describe this as the 1, 1 position. Describe this as the 1, 1 position. Or you could describe it like this. So the software engineer's method is to describe it like this. It's the, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9th entry. You could say it's the 9th entry of this one-dimensional array. So if you just imagine all the rows coming together like this goes here, and then the next one goes here, and they go in just in a line like that, it's just a one-dimensional array. It's just that you have to remember that there is 0, 1, 2, 3, 4, 5, 6, 7 columns, right? Or there's 8 columns, index 0 to 7, right? So in general, so I guess I'll specify there's 8 columns. So what you can say is that this is the 1, 1 position, right? But another way to say it is you could say it's the, let me look at my notes here. It's the I times the number of columns plus jth position of a one-dimensional array. So think of it like this, right? So we're going to 1, 1 here. So 1, 1 would get me 1 times 8 plus 1, which is 9. That's what we want, the 9th position, right? So it's how many, so this position right here would be the 0, 1, 2, 3, the 3, 1, right? So how many numbers do we have to pass by? Well, first of all, we have to pass by 3 times the number of columns. 3 times the number of columns. And then add whatever the entry into that row is, which is plus 1, right? So that would get me this index right here. So in general, if you're using the software engineer's method and you want to say, you want us to get the array of ij, you want to get the ijth entry of this 2D array, what you would write is array of I times number of columns plus j. And this will work exactly the same. It's just that this is actually a 1D array. We're just pretending like it's a 2D array. And this is actually a 2D array. But we'll figure out how to do something like this. That's the computer scientist method, but software engineer method is like this. So this is quite a bit simpler to actually set up, I feel like. So let's try it. So if I want to set this up, what I have to do is, I have to specify the number of rows and the number of columns, right? So, sorry, I don't have to specify it yet. I have to specify it from the user, but I have to just set a variable here that's going to be like int number of rows, int number of columns. So let's say scanf here, or else I should say printf. I'll say, come on, enter the number of rows, then columns. Right, so it'll do this. It'll be, it will be %d, number of rows, not crows, number of rows, number of rows, number of columns. There you go. And now, if I want to dynamically allocate this 2D array, that's going to be a 1D array, but it's actually a 1D array in the computer, but we can treat it like a 2D array. What we do is we say, okay, it's going to be an integer array, so int pointer, I'll say array. I'll say array 1. Right, so we have a pointer to an array, and this is going to be array equals integer pointer calloc. And I'll just write this code and then I'll explain it right after. Okay, so number of rows times number of columns. So while I'm writing, try to see if you can make some sense of it. And this was integer. And now, from here on, this was setting up the array. So from after these lines of code, we can access this array, ARR, as a 2D array by just doing ARR of I times number of columns plus j. And that's going to get us the ijth entry of the 2D array. Now let me explain what's going on in the code a little bit more here, though. So, okay, we're declaring our variables, that's fine. We're getting the input from the user. Now what's happening is that I'm declaring a pointer to a 1D array. It's really just a pointer to an integer. Right, so R1 is pointing to an integer. And then this next line is I'm saying, okay, well, at that address array, it should be array 1. At that address array, I'm going to allocate a certain number of spaces of type int pointer. Right? I'm going to declare a certain number of spaces here that each have a size of integer. Okay, so how many spaces? Well, how many spaces do I need in my matrix? I need the number of rows times the number of columns. That's how many spaces I need. So to figure that out, I just do number of rows times number of columns. So now if I were to compile this, I'll say software.
Which wouldn't Calog do exactly?
What'd you say?
Like Calog, like is that the one that creates the spaces?
Yeah, that's what allocates, right? So it's saying allocate how many spaces, how big is each space? Right.
So it's saying that there's gonna be over how many rows times how many columns, and they're all integers.
Yeah, they're all size of it. Yeah, they all have the size of an integer.
And what's the int pointer thing in the front?
Yeah, this is saying because since R1 is an int pointer, whatever I'm assigning it to should be an integer pointer as well. Since R1.
What's the difference between calloc and malloc? Because there's like two of them.
Yeah, calloc, you need to specify. What do you need to specify? You need to specify the. You don't need. What do you need to specify with malloc? I don't think I've ever once used malloc. I forget now. We talked about this yesterday. And I don't remember. Malloc.
I'm pretty sure.
They're very, very similar, like both of them.
I was gonna say, I'm pretty sure malloc just assigns like a big massive chunk of memory. It doesn't specify how many units of it, so you do n rows times n calls times size of int.
Oh, times size of int? Okay, I see, yeah. So it's a little bit more, like, I think it's like, yeah, it's how many, the size of the memory block in bytes. So if you use malloc, yeah, that's right. You use malloc, you would just multiply this by size of int. So we want this times the size of each block. So this is how many blocks times the size of each block. That's going to give us how many bytes of memory we need. And that should work the same. But I would just use calloc for everything.
And do we need to specify that in the malloc that each size is an int, or we don't need to? It's just one parameter for malloc.
No, it's one parameter, but you do need to specify that it's size of int. So like you see, it's like I need to specify here. It's just one parameter though, like that I'm typing in.
And isn't size of int always 4? So isn't it just easier to just say 4?
You could say 4, sure, that works. Yeah. But I'm just doing it in general here, so that you know you can just do size of whatever thing you're doing. So.
Alright, thank you.
Nope. Okay, so then we are getting errors. Let's see what errors. Expect format %d. Oh, I didn't put the ampersands. Still getting errors. Implicit. This is a declaration of calloc. Incompatible implicit declaration built in calloc includes. Oh, std.
Calloc is a part of stdlib.
Yeah. Thank you. stdlib.h. Still just unused integer. Okay, I unused them. All right. Okay. So then there we go. So then this will. I mean, it won't do anything. I mean, I can just enter it. I can say 5, 6, and now we have a 5 by 6 matrix. I don't know how to prove it. I mean, I guess I can use this last example, but this is the idea of how you set up an array here using the software engineers method. So any questions about this? Okay, if not, this is how you set it up. Like this is exactly how you do it. So then let's do the computer scientist method now, though, which I never actually used the computer scientist method in a practice problem, so let's see how this goes. So topic is computer scientist method. So I'm gonna have to hash include, probably include stdlib.h. That's what it was, right? stdlib.h, I'm pretty sure. So for here, the idea is that we're actually going to do a 2D array. Okay, so, well, okay, again, not really actually. So C has a lot of trouble with using 2D arrays, like actually having what would work as a real 2D array. So you have to always have a trick. So the first trick was the software engineer's method. The second trick is the computer scientist method. So the idea here is that instead of having a 1D array that just we keep track of everything, we're going to have an array of arrays. So we're going to have an array of arrays. So you can think of this as each of these. You can think of each of the rows. So here, I'll maybe highlight them. Each of the rows here is an array on its own, right? Each of the rows here is an array on its own. They have an entry 0 to 7, I guess, 0 to 7. But you can also think of collecting those into one array on the side here. And these also have an entry of indexes from 0 to 0, 1, 2, 3, 4, 0 to 4. So if I were to look for the 4, 4 entry, well, I would go to 4, 0, 1, 2, 3, 4. And that would be right here. So you can think of a 2D array like this as an array of arrays. So when I'm saying the array of arrays, I'm saying this is the first array. Each one of those things is an array that it contains. And that's kind of how we do it here. So let's see how we actually implement that into this. So we're going to first of all have to declare, of course, int, maybe I'll just copy this stuff here. So this won't change. We just need to get the information from the user, right? So get the information from the user about how big the array should be. Okay. Or from wherever. It doesn't matter how you find it. Question?
Yeah, I have a question.
Yeah.
Wait, but it's like if anyone even knows the answer to this, do we have to pass the exam to pass the course, or is it not like that?
I'm not sure.
It's a 50% exam, so
50%.
It's a 50% exam, but it depends on like what you've gotten. Like if you've gotten like really good marks, then like if you get like a bare minimum, you could pass.
Alright,
But like that's just I don't know. You can calculate it. It's on the course management thing.
Alright, thank you.
Okay, so let's see what we're going to do here with computer scientist method. So what I need to do is I need to declare an array, so int. Well, just like before how here we declared pointer to integer, what we need to do is we're going to use double pointer. So pointer, it's going to be array 1. Okay, so what this is saying is it's saying I'm going to point to a 2D array. Right, so this is something that's going to contain a pointer to a pointer. Right, it's going to contain a pointer to a pointer. Okay, so then for now, I'm going to allocate enough space at this location. So array equals integer pointer, right? Because array 1 is an integer pointer, so it's a pointer to a pointer. Because remember, we want the variable to store a pointer, right, to a pointer. This thing, right, we want, like, so the name of the array points to here, and what that is a pointer to this whole array. So it's a pointer. Okay, so the integer pointer, I'm going to allocate enough space. How much space? Well, first of all I need for this first allocation is the number of rows, right? I'm allocating the enough space in the rows. It's going to be number of rows. Right? And what is the size of, though? What do each of these things have to have the size of? Well, the idea is that each of them has to have the size enough to hold an integer pointer. Each one of these entries has to hold an integer pointer. Right? I guess maybe a better way to say this is that we have a separate array on the side here. Because when I say this, it kind of seems like the 0, 0 doesn't count. There's an array on the side here. This is what's holding all these things. And each one of these entries holds one of these arrays. That's a better way to say it.
So does that mean that we're going row wise?
We're gonna
In
go row
terms-
first. Yeah, we're gonna go row. So you see n rows is first here, and each one of those
Yeah.
things holds an integer pointer.
Okay.
Right? Each one of those things holds an integer pointer.
All right.
Okay, and now what I gotta do is for each of those, I gotta allocate enough space to hold the array, right? The blue array. So for each of those, so for each int I equals 0, I is less than number of columns. Sorry, I is less than number of rows. Come on, I plus plus. So for each of these, starting at 0, up to the number of rows we have, less than, not including that. For each of them, I need to allocate enough space. So array of I, so the ith entry of this array is gonna now have enough space. I'm gonna typecast it to integer pointer. I'm gonna allocate that space, number of columns, and how much, that's how many blocks we have. And how big is each block? What can each block hold? Size of integer.
Do we have to dereference ARR? Because we're looking. Like, do we have to dereference it once?
Good question. I don't. Let's try it. Let's see
No,
what
you
happens.
do not.
I don't think we do.
You don't? Okay.
Computer scientist method. CPS lab.
Do you know why they're called like this, or just the name?
What do you mean? Sorry.
Well, why is this a computer science method? Like,
I guess because it's more like you're actually doing. You're not actually doing a 2D array. You're doing a pointer to a pointer, but it's more technical, I guess. So that's why it's called the computer scientist method. Software engineer method is like less technical. Okay, but I do realize. Oh yeah, I just call it R. I don't know why I called it R1 there. That was the problem. There we go. It compiled. So now what's gonna happen? I'm gonna enter the number of columns. I'm gonna say 5 by 6, and again, there's nothing there. But we've created now a 5 by 6 array, right? And we can access the elements like this. We can say R of 1, 2, or 134, whatever, 1, 3, right? And that would give me the 1, 3 entry of this array. And that's actually how you do it like that. Okay, so I'll take a second and go through this again. Again, this one's a little bit complicated to think about. So I'll go through this explanation about this, exactly how we do this, what each line means here. So here we're just declaring our variables, getting input from user. Okay. The first thing we need to do is declare that the starting address, oh my god, will hold a pointer to a pointer. So think about that for a second, right? It's gonna hold a pointer to a pointer. That's what this first thing is here. All of these, so our first address is pointing to this array, which is all filled with pointers that each point to their respective rows. So pointer to a pointer. Pointer to a set of pointers, I guess. Okay, so now that we have declare that the starting address will hold a pointer to a pointer. So there, now at that starting address, allocate enough space for the number for each row, which will hold a pointer to an array, to an integer array. So that's what's happening here. At that starting point, at that starting address, which is going to be a pointer to a pointer, allocate enough space, so the number of rows, that's why it's going down. Oops, that's Word. Opened Word by accident. Allocate enough space going down so that each row here can have size of int pointer, because each row is going to hold an integer pointer. Right? And now for each of those rows, allocate enough space for the integer array, which will have a length of number of columns. That's what's happening here, and this is just so after this. So from here on, we can use like R of ij to access the ijth entry. Okay. Any questions? Any questions? Okay. I will take that as yes, I will take that as no then. Okay. So then that's everything for 2D arrays then. Any last questions about 2D arrays before I move on to structures? That's my last topic. Okay.
Sorry, yeah. So I got a question just about this computer scientist method.
Okay.
So at the top where you have your int main, I see how you have int argc and char double point. Is that necessary to have there?
Just how Genie starts it. We'll talk about that today, what that is. We'll talk about that today. But
okay.
Yeah, no, that's not necessary. That's just how Genie starts C programs with those things in there.
Okay.
For me, at least, that's how it does it. But yeah.
You can make a template.
That doesn't do it?
That, by the way.
Yeah, okay, well, probably should, yeah. Okay, so then there is our computer scientist method. So now I will move on to structures. So the idea of structures is that we're able to define our own kind of like a data type that can hold any amount of information. So, and any different types of information. So for example, our arrays could hold a list of integers, but a structure could hold an array of integers. It could hold also, just a name, or like a string. It can hold a couple number. It can hold any amount of combinations of integers and doubles and characters and arrays and everything we want, right? So for example, if I have like a person and they have a bunch of information about them, I want to contain all the information about this person in one instance, in one example, like one use of a structure. So first of all, to define a structure, let's do an example here. Maybe there's a specific example that would be good. Let's just see in general if I want to define a structure. Oh yeah, just to quickly say, so the structure is the general frame. It's like a general person. And then what I call an instance, or not just what I called it, but I mean, I didn't hear it called that in the course, but I'm pretty sure it's called an instance. So the instance of the struct is like a specific person, right? So the struct is just a general person who can have a name and an age and a height and all that, right? And an instance is a specific person who has a specific name and a specific age and a specific height. So if I want to just make a struct, which is a person, right? So I'll say struct person, right? I'm defining a struct. Notice this is before the main. Now I want to see here, I want to say that a person has these, we'll use name. So it's going to be a character array, which I'll call name. It has a maximum length, let's say 10. Right, so the name, they have a person whose name is has a maximum of 10 characters. Well, maximum of 9 characters, including the null. They also have an age, so an int age. Right, and they also have a height, so it's going to be a double height in meters or whatever. Doesn't matter. Right, so yeah, and that's essentially it. I mean, now I have a person. So now if I want to go in the main program and say create an actual instance of this person, I'm going to say struct person.
You need to put a semicolon after your structure.
Here?
Like after you define the structure, like open bracket, close bracket. Yeah, there you go.
Right there, right. This one right there, right? That's it. Yeah. Okay. So struct person is going to be I will say a person. I'll say Adam, I guess. So there we go. I'm pretty sure that it's not highlighting how I expected to highlight, but I think that's fine. It doesn't seem like it's going to cause a problem. Okay.
You have to compile it first.
Oh, I have to compile it for it to. Yeah. Okay. So structs. Study hall. Yeah, that's fine. Okay, so there we go. So now person is a struct. Is a recognized variable type person. So remember, this is a variable type. We have a new variable type called person. And to define, I say struct person Adam. So now I can give Adam enough. It's gonna be weird saying my name all the time now, but I can give Adam a bunch of values, right? So I can say that Adam dot name. Well, of course we start with the hardest one. Okay, name. I'm pretty sure I can just do this. I'll say Adam, right? Or you know what? I'll call it person 1, and the name will be Adam. Person 1, right? So the name is Adam. I hope that if that causes an error, then we'll look into that. And then I'll say person 1 dot age equals 19, and then we'll say person 1 dot age equals just some height of 190. There you go. And then so there we go. And then now this variable person 1, if I compile this, hopefully it works. So it does have a problem with this.
Did you mean person 1 dot height?
Oh, you're right. I did mean height, but that's actually not the error that's causing here. Yeah, the assignment. Yeah.
I was gonna say, I'm pretty sure you want to remove the struct. You just call it person 1, sort of like how you'd call int a. You know what I mean? Because we've
I
defined.
think you have to remove that one because
I think this has to stay. I think if I do this, it won't compile. Yeah, it won't understand what's happening. But I think, do I have to add a array brackets or something? Compilation failed.
Oh, you might need to use string copy.
Oh, okay. So
Because it's a string, and you're trying to put a string into a
brackets,
string.
and do strcpy. Oh yeah, no. I see what you're saying. Yeah, I see what you're saying. So do strcpy. What do I want to put it into? I want to put it into person1 dot name. And what
You
am I
have to
putting
include
in?
string dot h.
Oh yeah. Hash include string.h. And now it compiles. Okay, good. Thank you. Yeah, that's how you do it. So I'm gonna put Adam into person1 dot name. So remember the dot notation here is saying in this instance of the struct, every instance of person has a name, age, and height. So in this specific instance, I'm gonna assign the name to Adam. And now if I want to print this, I can say, okay, well, printf. I'll say a little profile. New line. I'll say printf. I'll do a couple, so it's gonna be name, age, height. So name is %s person1 dot name. Someone's got a little bit of an echo in the background or something.
Well, it might be me. It's because I'm like building something.
Oh yeah. Could you mute? So yeah. Age is %d person1 dot age, and then height is %lf. Oh, I guess I'll do a lf here. 0.45. Oh, I should put new lines, shouldn't I? There's no new line there, but new line there. Person1 dot height. Okay, so if I compile this, build it, execute, there we go. So you see now this person that I've created, person1, whose name has a name Adam, height, age 19, and height is 190.45, whatever. It's an instance of this general struct. So the struct is the general idea. Every instance of the struct has these 3 variables because I defined it like that. And then I can specify certain information about each struct here, right? If I want to. And yeah, that's the idea. You can combine some dynamic allocation in here with these things like that if you need to. And you can combine a bunch of ideas here with this. But this is just the general idea of using a struct. So any questions? We can take a moment. I think we're doing okay on time.
So structures always have to be outside of the main, like the
They're defined
declaration.
outside the main, yeah. They're defined outside the main.
So they can't behave like functions.
In a way, they're not really the same thing. Like they don't do the same thing, but yeah, the way you write it, yeah.
You can have as many things in them as you want.
Yeah, you can.
Okay, thank you.
I have a question.
Yeah.
Sometimes there is a name after the bracket before the semicolon in the struct. What is that name for?
So that's exactly what I'm going to get into right now. So the next thing is that we can do type def. And essentially, I don't want to write struct person every time. I want to have a nice way to write struct person. So maybe I'll say per down here. So now for the rest of the code, so type def up here, per down here. For the rest of the code, if I write per, that is absolutely identical to writing struct person. So right here, I could define per right there, and this would work exactly the same. So per is just like a short form way. It's as if I can just say like int person, right? But now I just say per person. Right? So it's like defining a short form way to access these things. Instead of having to write struct person every time, I can just define a type def, and it's like that. Interestingly, I could say type def int number, or I'll say int whatever. I guess number. Pretty sure this will work. Number. Come on. And now if I want to say, okay, int num1, that will be the same thing as saying number num1. If I just compile, I think it'll work. Didn't work. Previous declaration, no linkage. Yeah, hold on. I'm writing something wrong here. Type def, let me see.
You have to have the brackets around, like starting and closing int, I think.
Don't you have to define your variables before your main function?
That's also true.
Let's see. Yeah,
I thought type def had to be preprocessor.
Okay, let's take a look. I'm gonna look at this lecture slides and see.
And I meant squiggly brackets, opening and closing after int, but before number.
I see. Okay.
Is there a technical name for those, or are they just squiggly brackets?
I don't know. Sets. That's what I'd say. Set. There you go. Yeah. So I say it up here. That was the problem. I say it up there. Well, still, this compilation failed. Num1.
Does it say why?
Previous declaration of num1 was here. Int num1. Oh, I'm just declaring num1 twice. It should be num2. Now it finished successfully, and I'm just not using the 2. There you go. Now it works. So what I said, this up here is saying that instead of saying integer, I can say number. Of course, that's not shorter, so that's not helpful in this case. But the idea is you create an alias. That's what it's called, an alias, right? So the alias is number, alias is per for this struct. It's useful for structs because this is a little bit kind of long to write, I guess. I don't know. So you create a type def, and they do it a lot in the example problem. So it's good to understand what they're writing. So you say type def right before you do the struct. Right afterwards, you put the alias you want. And then for the rest of the code, you can just use that alias. So yeah. Okay. Any
I have a
questions?
question.
Yeah.
So does it matter where you put the struct, or does it have to be before, like?
It has to be before the main. It has to be before the main.
It has to be before the main. Okay. So kind of like the functions. Okay.
Yeah, exactly. A quick
I don't know
note,
if you can
yeah,
prototype
go for it.
structures, but you might be able to prototype structures.
Like initialize it before?
The same way you do functions. I don't
Yeah.
know if you can, but you might be able to.
I've never seen it, so I don't know. But yeah, you might be able to. So quick note is that I can also declare a person a little bit of a different way. I can say per person2, right? And I'm going to declare them. I'm going to give them all the values right away. I'm going to say name is, I don't know, Daniel. That's the first name that came to mind. It has what was the next value? It was age, so I'll say, I don't know, 18. And height is going to be a double, so I'll say 150.3. And there we go. Now I have put a semicolon. And now I have a new person 2, named Daniel, age 18, height 150.6. So you see here, we can define a person in a slightly different way. Just have to make sure that these are in order. So it's good to know that you can do this here. And they'll work the same. If I say, here, I'll copy this. Can I do that? Yes, I can. Say profile 2, it'll be person 2, 2, 2. So if I compile, build, execute, there we go. There's the thing. It's all the numbers. I just didn't put a new line there, but yeah, that's the idea. Okay, so that is the general idea of structs, how to use structs, all this kind of thing. Any questions?
Could you say again what the type def number thing is for, and the number num2?
This one here. This is just giving you an example of like how type def works. The main use is right here. This isn't necessary for the program. This isn't at all necessary. Like this line of code and this line of code, don't do anything, and this line of code, don't do anything to the program. Like of the names here. This is just me showing that you can type def variable type. So what you're doing is you're taking a variable type, you're giving it an alias, you're giving it a different name. So for example, I'm giving it number. I'm giving it a name number. So when I say number num2, that's saying num2 is a variable of type integer, because I said that number is an alias for integer. That's the whole idea. It's not very useful here though. So doesn't do anything. The main use is when you have a struct and you have to say struct person, you can shorten that to just like per or something simple. And yeah. Okay, so that's structs. Any more questions about structs before I move on to linked lists? Oh, I guess I should mention passing into a function, so I'll do that quickly. I'll say I'll define a function. I'll do it after. So I'll say I'll define a function. It's a void function, and it'll be called name. It's going to take in a struct. So I'm going to call it per, and I'll say input. And I just want to print the name. Maybe I'll say printf. The name of the person is, and it'll be %s, and it's going to be input dot name. And if I call this function here, if I just say like, I'll say printf sending person1 into the function, then it'll be print, well, not printf, I'll just call the function. I'll just say name, and who am I sending in? I'll send person1. So let's see what happens when I run this. So sending person1 into the function, the name of the person is Adam. So I sent person1, see, so I called the function with person1 sent in. Then I go to the function, you see here, well, the function takes in a person variable, right? So I could also say struct person here, and that would be exactly the same. Remember, per and struct person is an alias, so it's exactly the same. You can say per, just another name for it. And it's just going to take in, it's going to get the name of whatever struct, whatever instance of the struct was inputted. So input.name is the name of whatever was input into the function. So I could do this again with, person2, and it would just give the names. There we go. So sending person1 into the function, name of the person is Adam. Sending person2 into the function, name of the person is Daniel. Profiles, and there we go. So I'll fix the new line problems, but yeah. So how does everybody feel about structs? So don't need a new line there. Hopefully everybody feels okay. There we go. There's my final version of the code. So we're going to move on to linked lists now. Structures and functions. We're going to move on to, we're going to move on to linked lists. So quickly before we go right into it, we need to first, okay, let me describe, let me just see here. Yeah, okay, first, quickly before I do this, I'm going to do one more thing. So what I want to do is, let's say, oops, what was happening there? I don't know what was happening. Let me zoom out a little bit so you can see more of the code. So let's say I want a pointer to a struct. So I'm going to say, keep that here. I want a pointer to a person struct. I'm going to call that PTR. It's going to be a pointer. And it's going to either point to person one or person one or person two. You don't know which one. Doesn't matter. For now, I'll just say PTR equals the address. Do I say the address of person two? I think I say the address of person two. I think that's going to work. Let's see. And let's say I want to access the name of the person that's held in that pointer. We don't know. So that pointer could point at a bunch of different instances of the struct. But what I want to do is I just want to access whatever right now is being held in that pointer, whatever that pointer is pointing to. It's an instance of a struct. And I just want the name of the person. So if I say printf name of person held in struct. Oops. And it's going to be a string. And now, how do we actually access this? Well, what we do is we use a different kind of notation. Okay. So what we're going to do is we're going to say PTR pointing to name. So it's a little arrow. It's like a dash and a greater than sign. Right? And that's literally like a little arrow. So whatever pointer is pointing to, go to its name. So pointer is not an instance of the struct. Pointer is a pointer to an instance of the struct. In this case, person 2. Let's see if this compiles. Yeah, it does. Okay, good. So you see here, name of person held in struct Daniel. That's what we wanted. And then we do the rest of the stuff here. So maybe I'll put a new line there. There we go. So this is quickly to understand pointers to structs. So PTR is a pointer to a struct. We're assigning it the address of person 2. And then to access the name of the person held that pointer is pointing to, we say PTR arrow name. I could do PTR arrow age for the age, PTR arrow height for the height, all that. Understanding this is what lets us do linked lists. Okay. So any questions before I move on to linked lists?
So you have to point it to the function and not the struct. Is that what because I don't know, I'm just a little confused. Why are you pointing it to name?
Well, because I want to get the name out of it. I want to get, so pointer is holding an instance, the address of an instance, and I want the name of that instance that it's holding. So I say pointer arrow name.
So this printf statement, it would print out Daniel, correct?
It would, yeah. It would say name of person is Daniel. Equivalently, right now, I could say person to dot name, right? I could do that. That's because I know I assigned it to person 2. But what if the code is assigning what the address of pointer is? Then I don't know specifically right now I want to see person 2. So I just want to know the name of the person held in the struct. So that is going to be PTR arrow name. So yeah. Okay, any questions before I move on?
Can I see the top of the code?
Top of the code?
Yeah.
So void function doesn't return anything.
Or you change the base by just like person, you don't have to use struct person.
Exactly. Yeah, exactly. I used an alias here. But remember, anywhere that you see per is exactly the same as saying struct person. Okay, let's do linked lists. Yeah, sorry.
Daniel's a short person.
Yes. Exactly. So linked lists. That's the topic for this document. So, topic linked lists. So here we're gonna have. So okay, let's talk about first the idea of a linked list. Okay, so the idea of a linked list is I have an ordered set of instances of my struct. Okay, so it's like as if I have so my struct has a bunch of instances. The example they use is a bunch of elephants at the zoo, right? And I want to know the order of these instances, right? The order of the elephants. So, well, not only, okay, I want to set an order, and I want to be able to go down the list in that set order, right? So to check each one. Okay, so first I'm going to have to define a struct, right? First I'm going to have to define a struct that is going to, that this linked list is going to use as like the main thing that we're counting, right? Or the main thing that we're ordering. Each instance in a linked list is called a node, okay? And it has two things, okay? Well, it has two sections, and it can have any number of things as usual. So I will say struct. Let's still do people. So struct person. Oh my god, person. So I'm going to define a struct, and there's two important sections when I'm doing a linked list. Section 1 is just the actual values. in the instance. Okay, so I'll say again. I'll just say I could copy and paste it, but I'll just type it again. So I'll just say it's going to have a character array of length 10 for name. It's going to have a integer called age, and it's going to have a double called height. Section 2, okay, section 2 is the important thing that makes this a linked list. It's going to have a pointer to the next instance in the linked list. So I'm going to define a new one. So I'm going to say, I think I can say person here. And am I allowed to use person inside? I think I am allowed to use person inside like that. So a pointer to a person called next. Okay, pointer.
I think you need to do type def before you do.
You're right. So this is a very important thing. It contains, each instance contains a pointer to the next item in the list. Okay, so let's say we have a list of people in a class, right? So, and I think I'm going to jump right to, let me see this for a second. No, you know what? I'll do this non-dynamically allocated. Let's say I know I have 3 people in a class, okay, and I want to go through this list of people. So this is a non-dynamically allocated allocated. So what that means is we know the length of the list, right? We know the length of the list. Okay. So now I'm gonna initialize 3 of these people. So person 1, person 2, person 3. Okay. And now each person 1 dot name. Oh no, I have to do a string copy. So I'm gonna say assign values to person 1. So I'm gonna say strcpy person 1 dot name, and I'll give them a name. So I'll make it myself again, and I'll say person 1 dot age equals 19. Person 1 dot height equals 90.45. Okay, there we go. Assigning the stuff to person 1, and then I'm just going to duplicate that a few times. So I'm specifying the information. You get this from the user. You could do this however you want, right? So, but I'm just specifying the information because this is a non-dynamically linked list, right? So, Daniel. Oh my God, I could spell. 50.45 is fine. And then person 3, I don't know. I'll do Charles. Charles is 20, and he's 90 centimeters tall. That's about right. Okay, so we have 3 people. I've initialized all their values. Now I want to go through.
That's so mean.
That's what? That's so mean to Charles? Yeah. Yeah. So I have all these people, but I want to create a linked list. Right now it's not a linked list. It's just 3 instances of a struct. So what I have to do is I have to link them together. So what I'm saying, what I mean when I say that is I have to specify an order. So what order I want, I'm going to say person 1, person 2, person 3. So what that means is that to create this linked list, first of all, I need a starting position, a pointer to the starting position. So I'll say person pointer start. Yeah.
I was just gonna say you kept person 1 as the variable for all 3 persons, by the way.
Thank you for telling me. Gotta switch that. 43. Okay. Thank you. So I'm going to define 2 pointers here. One called pointer and one called start. So the start pointer is going to be the start of the linked list. So what's the start of my linked list? Well, start is the address of person 1. That's it. Start is the address of person 1. Oh, I guess I have to, I realize that's not been declared yet, so I have to do that here. Right. Start is the address of person 1. Now, what's the next person in the list? I have to go into person 1 and say that person 1 dot next is the address of person 2. what's the next person? Well, I have to say that person2 dot next is the address of person3. And finally here, what's the next person after here? Well, I could go in a loop, and maybe we'll try that. I could say, okay, well, go back to person 1, and that's the next person in the list. Or I can end the list here, and I'll say person3 dot next equals null. There's no next person. So now they're linked together. There's a sense of order here. The start is person 1, and the next person is person 2 and person 3. Now, what's the point of this? Well, notice here, if I wanted to do a profile on each person, I had to separately type a profile on each person. But now I can do one profile. I can say for int I equals 0. Hold on, is that how I do it? Let me see. For int I equals 0, I think I have to look at a example quickly. Here, yeah. There we go. This is not what I meant. So, we want to go through each element in this linked list. So what I want to start with is I want to start my pointer at start, right? I want to go until PTR, the current pointer, is not equal to null. And I'll explain this once we actually get to the actual code inside the loop. It might make more sense there. And each time I want the pointer to become whatever the current pointer is pointing to, and it has in its next field. So I'm gonna that might not make much sense. I'm gonna explain that when I write the code in here. So the idea of this part is I want to write a profile for each person in the linked list in one go, in one section of code with a for loop. Okay, so what I'll do is, okay, I'll say printf. You know what? I'll just copy the profile here. Say this profile is what I wrote. So we'll put a profile in like that. So we don't even need a new line there. That's fine. Actually, maybe we do need a new line. So name is, well, it's not going to be person1. It's going to be, well, I have a pointer variable that's moving. The pointer variable is going between each person. So it's starting at start. Okay. Each time the loop runs, it's assigning itself to be whatever the next item in the list is. So all I need is I need PTR, whatever the pointer is currently pointing to, the name there. I need PTR age, and I need PTR height. And now, hopefully, linked list. This doesn't compile. Okay, let's see what happened. Per next, it doesn't like how I said. Let's see what it said. Okay, give me 1 second to figure that. String.h. I didn't put string.h here. Include string.h. Unknown type per. Okay, so it doesn't like that I use per here, so I think I have to use struct person star, because I think it gets confused because I haven't. Yeah, there you go. It's just that I can't use the alias inside the struct because the alias, I guess, is defined here and the struct is defined first. There we go. And there you go. Look. So this code, I only wrote this once, and now it goes through the linked list. It goes through the linked list, and it does the profile for each person, and it stops on the last person. So let's look at the code and try to understand exactly what's happening here. So, anybody stop me if you have any questions? I'm just going, but yeah. We open maybe discussions. Maybe I should have discussions open if anybody wants to see or wants to ask me a question. Oh yeah, I feel like I should have had open. Okay, so let's understand what's happening here with exactly in this section. So our profile starting at our pointer is start. Now what's our pointer? Our pointer is a special, it's a pointer obviously. It points to an instance of our struct, any instance, okay, that's what's going through in the for loop. Each time the for loop iterates, it's going to the next instance in the linked list. How does it know what the next instance is? Well, go into each instance, and each instance itself has the field next. And next is the address of person 2, next is the address of person 3, and the next is null for this one. So notice null is the end. So we want to go until the pointer is null. If the pointer is null, then we don't want to go anymore. Okay, and so then here we just do each thing. So in this code here, what is pointer? Pointer is whatever the current thing, whatever the current instance in the list, whatever node we're at, is pointing to. So the name of that is PTR arrow name, PTR arrow age is the age, and PTR arrow height is the height of whatever the current one is. And we just have to define the start, wherever we're starting. But I could have started the second person. If I want to start the second person, I just say PTR is the address of person 2. And now it's only going to have Daniel and Charles, right? Because Adam is not there at the start. There's nothing that points to Adam. Let's see what happens if I assign the next of person 2. I'm going to assign that to be the address of person 1. Let's see what happens. I hope nothing bad happens. So it finished, execute. It's going to go forever, right? Because it's going to link, it's going to go, I'm going to close this before anything bad happens. But so it's going to go forever because you see what's happening is this for loop is saying, okay, well, let's start at person 2, I guess. Do their profile. Increment. Okay, what's the next person? Go to person 2. Look at what their next field has. The address of person 3. Okay, is that address null? No? Okay, then let's just do this. Done. Increment. Let's see what's the next pointer. Go to the person, so we're at person 3. Now go to person 3. What's the next field? Person 1. Is that null? Nope. So do this with person 1. Increment again. What's the next? Person 2, right? If I go to person 1, the next field has person 2 in it. And then it just keeps cycling like that. Is that null? No. Does the profile? There's no null. So to get it to be null, I have to actually put a null somewhere. And I'm going to start at start. I could just, the start isn't super necessary. I could have just said person 1. It's just that it's good to have a start variable because maybe sometimes you want your code, you want it to set like where the start is. So that's why I say start is the address of person 1. And yeah, so that's linked lists. We still have dynamically allocated linked lists, which is a whole other thing, which we'll get to next. But that is essentially linked lists. So, any questions about this? I know I'm going fast. I know I am. So if you have any questions, if I'm being too confusing about something, then tell me, and I will.
I'm just curious how the pointer, like what the pointer points to. Like, is it the address of, like, the structure? Like,
yeah, it's
like
the address.
person
It
1,
is.
person 2.
Exactly. See, so person2.net. So it starts at start, and that's an address of person 1. It's an address of the instance of the structure.
Right. Okay. Thanks.
Okay. No problem. Okay. Another question?
The best way to think about a linked list is to try and think about like a catalog. Think of like a catalog of items, maybe like on Amazon or something.
Mm-hmm.
Each item has a price, a description, a name. That's like one structure. Each item is one structure. And to go from one item to the next, like if you want to search the catalog, it will move through each item until it finds the one you're looking for.
In order,
yeah.
Right? It'll go in order. Exactly.
Usually alphabetical. I don't know.
Yeah.
Probably not in real life, but that's one way to think about it.
Okay.
Does it like go through structures or like lists? Or are they interchangeable?
It's a list of structures. It's a list of structures, right? A list of instances of the structure.
Okay.
Right? So, yeah. Okay, so let's do dynamically allocated linked lists now. They're not terrible.
Wait, could you summarize a bit? So you add the two things, you do the structure, right? Like, could you
Where? Sorry, start at the top here.
Yeah, like, so you name the struct, you define it.
Yeah. I'll do a summary here. So yeah, we include these two things. Then I'm defining the structure to be person. The person has two sections. It has what actual values does each person have. And then very importantly, to be a linked list, you have to have a pointer to the next. It's a pointer to the next instance in the struct. Okay, I typecasted as, not typecast, but typedefed it as person. So now in the main file, I'm going to define two pointers, one called start and one called pointer. So I'm going to use these to kind of come at the end, so we don't need them necessarily right away, but yeah, then I'm going to define 3 instances of the structure and give them all values. I'm also going to say that start is the address of person 1. That's where I want my linked list to start, with person 1. So the actual
at Adam. So it starts at Adam, and then how does it go to the next person?
So that's what's happening down here, right? So it's saying, okay, start at Adam, do this profile. Then what happens is this line of code right here. It's saying that pointer is now whatever. So pointer right now is holding Adam, right? Person 1. So the new pointer.
Adam is start.
Yeah. So new pointer is going to be whatever the next field is in the current pointer. So in the current pointer is Adam. The next field is person 2.
So in some sense, it's kind of like an I++, but like with next instead of.
It is, yeah. That's why I even said increment a few times by accident. It's not incrementing, but it's just saying it's the next thing. What's the next thing? So usually in for loops, we say the next thing is just the next number up, but here it's the next address. So to find the next address, you say, well, what is the pointer right now pointing to? What is it in its next field? That is what I want the new pointer to be.
And then when it becomes, when it reaches the third person, it's null, so it doesn't do. It just displays Charles, and then it just stops.
Yeah, because the for loop goes until so long as pointer is not null.
And that's it. It's just that.
That's it. Return 0.
And the structure is the same.
Up here, like this, yeah. So I'm going to use this now, actually. I'm going to use this to do the dynamically allocated ones.
What's the difference between type def structure and just number structure? Is it like the same thing, just a bit different, or?
Well, type def, by putting the word type def here, I'm allowed to do this per here, right? That's what it is. And so I can say per instead of struct person every time.
But it's the same thing. It's like everything else was.
It's the same thing, yeah. Just an alias.
Wait, are you saying that in the main function you can use per if you have the type def struct person rather than the struct person?
Yeah, you could. Sorry, can you say that again? You kind of cut out in the middle of that. What did you say?
No, I was just clarifying with the type def struct person versus just struct person in the function by itself. You're saying that adding type def, you can use it in the main function per.
I can use the word per in the main function.
Yeah.
Use the word
but
per.
if you didn't have the type def, you couldn't actually use
I would
per.
have to say struct person every time. In all of these, I'd have to say struct person, struct person, struct person.
All right, makes sense. Cool.
So dynamic. Okay, so here we have, we're going to do dynamically allocated linked lists. So I have the same struct as before. Remember, so the struct has two sections. Section 1, which is the actual values of the instance. Section 2, which is a pointer to the next instance in the linked list. So now we're gonna do dynamically allocated, because what that means is that we don't know dynamically allocated linked list, which is that we don't know the number of nodes in the linked list before, right? So for example, what's gonna happen is the user is gonna input some number of instances of the struct. So some number of people, the user is gonna keep inputting it. And we wanna collect that into a linked list, and then we want that linked list to have any size that we need. Okay? So, the first thing to do, I'm pretty sure we can do this all in a do while loop. I never done it in a do while loop, but I think we can do that. Oh, I'm realizing there's a typo in my, not an error, but a typo in my notes. confusing because I was like reading an example to do the general case, and I used the word from the example. So we declared our structure. Anyways, we declared our structure. Now in here, I want to declare 2 pointers again. I want to have a per pointer, which is called start. It's going to be the start. And I want to have a per pointer, which is going to be PTR. Okay? So that PTR is going to point to any random one, and start is going to be the address of the first one, specifically. So what we first have to do is that we don't know that we have, I can't just say like per person 1, right? Because I don't know how many people there's going to be. I don't know how many people there's going to be. So to start, I need to say start equals, so remember start is a pointer. I'm going to typecast that to person pointer. And I'm going to allocate it enough space to have one size of per. So think about that for a second. I'm giving start, which is a pointer, to a person. Enough space, I'm allocating it, the enough space to hold one thing, and that thing can be the size of person. Okay, and then I'm just going to say PTR equals the address of start. PTR is the address of start. Okay. So that's what PTR is currently pointing to. We don't actually, I guess that isn't necessary right away. We can do it a little later, but I guess it's okay. We can do it. Doesn't matter when we do it, so that's fine. So now I need to prompt the user to enter the first person. So I'm going to say printf. I'll say please enter the name of the person. I'll say new line. Oops. Say new line. I'll say scanf. What am I doing? I'll say scanf %s. Oh no, I need to do fgets. I realize. Oh, and now we're gonna have trouble with the thing. Hopefully, someone remembers the fix.
F-flush?
F-flush. That's what. Yeah. There you go. Okay.
If you're just entering a name that has no space in it, you can just use a scanf, and that won't have that
right.
problem.
Okay, then let's just do that. Yeah, I don't want to have problems with strings. So yeah, okay. Let's just say scanf %s. I want to assign that to start.name. So whatever start, you know what? I'll call it ptr.name. I'll call it ptr.name. So it's what the pointer is currently pointing to. .name. Okay. Those are equivalent because it doesn't matter. PTR is pointing to the start, so it's fine. Okay, so enter the name, and now I just need to say, well, I guess I'll duplicate this a few times. So please enter the age of the person, ptr.age.
I should warn, if you're doing non-string or non-array variables, you have to do ampersand and then in brackets ptr.age or ptr. Something else. If it's not a string or an array.
Oh.
Because it needs an address. It's a scanf. So you do address of p pointed age. Does that make sense?
I think I actually just do an arrow because name. No.
Yeah, you do PTR arrow name.
I don't think we need the ampersand for this because name as a variable is the address already. Right?
No, you don't need an ampersand for anything that isn't an array or a string. Sorry, you need it. You don't need it for an array or a string, but you need it for non-arrays or strings.
Yeah. So for here, I would say, oops. For here, I need that, right? I don't need the dot. Sorry, I'm not doing the dot. PTR is not an instance. PTR is a pointer to an instance. So
I don't know if it has to be bracketed or not either. It might have to have ampersand and then in brackets. We'll see.
Let's try this first, and then we'll decide. We'll see after what happens. Yeah. So please enter the name of the person. Please enter. Oh, the name. Last one is the height of the person, and it's going to be a %lf, and it's not going to be name. It's going to be height. Okay. So now the user is able to input information about this one person. It's going to store it in start. Okay. Now we have to say, does the user want to input a new node? So is this linked list just have one person, or is there more? Most likely more people. So I'm going to say printf. Do you want to enter another person? And just say 1 for yes and 0 for no. There we go. And I'll do scanf it'll just be a %d just to make it simpler. You'll say %d response, and I just have to declare an integer int response. Like that. So now the user can input if they want to enter another one. Okay. While response, while response is true, right? While response is true. First of all, I want this user to be able to input every time, right? This definitely could be a do while loop. I think I can just hold on. So yeah, we want the user to be able to do this many times. So I'm quite certain I can say do and end it with while response. I never done it like this before, but I'm pretty sure that works. So do this one time.
You'll need to redeclare or reallocate every time they want to enter a new one. So that has to be at the top of your code in the do while loop.
Oh yeah, I see. Okay. So then, okay. So this just say, no. Then yeah, then we're gonna have trouble here with this because I also have to say start.
I think the only thing is just at the end, after response, you just change the pointer to the next. Right.
Then I would just have I'd have to say an if statement here. I'd have to have an if statement. If they said yes, then I have to say create a new person. If they said no, so create a new person's at the start. Oh yeah, so then now I just say no. This is gonna be too many problems now because I'm gonna have to remove. So I think this makes more sense if I just do it like this. Yeah. So we'll just do it like this because there's gonna be too many problems with. So I create the first person. That's a separate thing. Create the first node is a whole separate thing there. Then the user has the ability to enter more nodes here. So if the response was yes, then I need to say that whatever pointer the address, let me get this right, next. So pointer next is an address, is a pointer to a new instance of this struct. I want to assign that the exact same thing up here as what I said right there. I want to assign that to have a new instance of the struct there. Enough space for a new instance of the struct there. Okay, and I'm going to set the current pointer to be whatever I'm going to set the new pointer to be whatever the current pointer is next field is. Current pointer is next field. Yeah. And now we're pointing to the next item in the list. We still know the start. Start is this thing up here. Right? Start is the address of the first one. And so now I can do the same thing. I do the same process. I can say, please enter the name of the person and all that. Let's do this. And then at the end, you ask, do you want to add another response? And if they do want to add another response, then you go back up here. You say, okay, well, the next, create a new allocated, area of memory wherever the address of the current pointers, whatever current instance we're on, its next field is an address. Create a new instance there. And allocate enough space for a new instance there. Okay, and then set the new pointer to be whatever the old pointer was in its next field. The next field of the old pointer. That's what the new pointer is going to point to. Kind of hard to say, so sorry if I'm messing up, but yeah. So once I'm done though, once the user says no, then the last thing I need to do is I need to say that whatever the current pointer's next field is, set that to null. And there we go. There's the dynamically allocated linked list. I'm going to take this old section. I'm just going to use this exact one. Write a profile for each. And this should work just as well. Yep. I'm going to just take that, write a profile for each. And now what this code is going to do, okay, well, oh no, it did compile. I thought it was going to compile. I need to have, I did use calloc, so I have to say hash include, what is it? stdlib.h. Compile. Still more errors though. Struct person PTR. Address of start. Well, it does compile. I just want to see what's wrong. What is it not like? Scanf %d response. Oh, I need to have that there. Oh, and here too. I have that there. And now, line 24. This right here doesn't like this for some reason. PTR is the address of start. Oh, start is a... Yeah, actually, not the address of start. It's just start.
They're both pointers, right?
They're both pointers. So PTR is
Yeah.
start. Yeah. So yeah, there you go. That's what it was. Okay. So now I can open this and I can type in people's names. So Adam, 19, 190. Do I want to add another one? Yes, I do. Name of the person, Daniel. Age of the person, 18. Height of the person, 150. Or 1,560? Yeah, probably. And Charles, 20. Only 90 centimeters tall. And I'll add another person. I'll say Tom. Age of the person, 34. And height. Oh, no, none of that, but very tall. Do I add another person? No. And now there's a profile for each person that was created. That's it for dynamically allocated linked lists. That's it. So any questions now? It is 2 o'clock. We do have command line arguments, although command line arguments are very short. It's a very short thing. It's 2 definitions and 2 functions. But yeah, so let's take 2 minutes now to figure this out. And then, yeah, so okay, any questions about this? Because I know this is a lot. This is like the hardest thing in the course, probably, I would say.
Definitely.
Yeah. So, ask any questions. Otherwise, I will move on to command line arguments. Maybe I'll open
So all we did was just change this to a prompt, basically. This struct person to a prompt instead of a progression kind of thing. That's basically it.
Yeah, essentially I'm able to create I can allocate as much space as I want for this linked list, because I just allocate, if there's another person, I just allocate enough space for that new person.
Which is the size of person right here.
Exactly, because of this line right here. So if the response was yes, then at the address of whatever the next field of the last instance was, assign that enough space, right, for one person.
Oh, okay.
One person.
But you said if it was yes, meaning that we had entered. What was the prompt for next person again?
Do you want to enter next person? 1 for yes, 0 for no.
Okay, yeah, that makes sense. Thanks.
No problem. Okay, then yeah. Any questions about linked lists? Otherwise, I will do command line arguments. Command line arguments, I don't really actually know how to apply them. We're not really, I mean, it's a test, so we're not going to apply them in anything. I think the idea is just to understand what's being written. So for the first time, I'm not going to erase this, because that's what the command line arguments are. So, yeah, let's go through this. Again, it's only 1 page in my notes, so it's really not bad. So the idea is that when we're using command line arguments, the main function is a function. I mean, we call it a main function for a reason. It's a function that's being called on by the operating system. Okay, so it's int main. It's a function, like we declare it just same. It has parameters, and typically we say void in the parameters because we don't want any parameters for it, because we're not going to input anything into the main function. But we do when we're using command line arguments. These are the command line arguments, right? So there's 2. There's always 2. So the first one is argc, which is just it's an integer, and it just counts how many arguments you're trying to put into the main function. And the next one is an array of strings. Okay, so remember, it's a pointer to a pointer, like we had before, like when we did the computer scientist method of 2D arrays. This right here is saying, okay, expect an array of strings. Okay, a pointer to a pointer. That array of strings is going to contain all our information. It's going to contain all our information. First of all, the 0th element of that array is just the name of the main file. Okay, it's just the name of the main file. Then so that means that int argc is always 1, at least. It's always at least 1. Then the next value, the first entry in this, is going to be whatever we want it to be. It's the first thing we enter into the main file. It's just, so these are like having inputs to a function. It's just that we have inputs to the actual main file now. Okay, and so those strings can be, of course, regular strings like sentences and stuff like that. They can also be numbers, which we then want to convert from a string into an actual number. And they can be characters, and they can be whatever you want. They can have any number of them, because remember, this is a 2D array. It's an array of arrays. So yeah, okay. So let's try it now. Well, there's not actually that much to try. Let's just see what's gonna happen. Even let me see here, because coding it, there's not much to code, and they didn't even go through exactly how we're supposed to do it from the command line. So the idea is that, okay, well, how do we call this function? If this is a function, how do we call it? Well, I can go to my thing here, and I can say run, and I say cmd, and so we have our command window here. And from here, I would be able to call the file. I haven't gotten that working yet, and my professor didn't really explain how to do it properly, so I don't really know how to do it. But this is the idea, is that you would call it from here, and then you would send arguments into it. So what we have to know for the exam, though, is just like, how do you use these arguments, right? So afterwards here, I can use argc as a variable. It's a variable. I declared it in there. Argc is a variable, and it's just the exact same as argv is the variable that we can use. So if I want to turn, let me see this quickly. If I have an entry here, and it's a string, but I know that that entry is actually a double, let's say it's a double, and I want to turn that into like an actual double and put it into a double variable. So what I do is, first of all, I have to include #include stdlib.h, and this gives me two new functions, so atoi and atof. Okay, atoi returns an integer, and atof returns a float, which is as you probably would expect. So if I declared int temp equals atoi, and I put something in here that's a string, like 45.7, right? If I put that in there, what this would return to me, and I think actually if I can compile this, I can say command line arguments. Don't really care that I spelled that wrong. That's fine. It doesn't like it. Unused variable temp. Oh yeah, then I just say printf %d temp. It prints just 45. So it returns the integer. It always rounds down, right? So atoi is a function that we're going to use here. It turns a string into an integer. Then if I said atof, it is the actual full float. Oh, didn't compile. Oh, still didn't give me 45 because I'm doing %d. Let's see, %lf. Oh, doesn't like it. Let's see what's happening. lf expects double. Yeah, this has to be a double. Of course. There we go. 45.7 is the value that's stored in temp now. So it takes that string and turns it into a actual double. So we can assign things to it. So for example, if I said like argv of 2, the second argument, then I'm pretty sure that would work. Let me think for a second. Strings. I think that would work. Let me check the slides quickly.
I'm pretty sure you would need two like two square brackets because you need to specify a specific character, wouldn't you?
Well, if I
guess
specified
if you're looking
it
for strings, that makes sense.
This would work, right? This, which is what I wrote here. I think that would
so.
work. Again, there's really no examples of this. It's all just text and using atoi and atof. So for the exam, know how to use atoi and atof, and generally what these means. Remember, argc is the number of parameters or arguments you're putting into the main function. And char argv is the actual 2D array that contains all the strings. And remember, they're always strings. So to convert it from a string to a number, you use either ATOF or ATOI.
Wait, so I didn't get that first part because I was on the other screen. You had 45.7 and ATUI. Did it print 45, right? Like, what was there? I didn't see it.
As ATOI, you said? ATOI?
Yeah.
Yeah, if I do
As
that,
well, it was
45.
Yeah. Okay.
It rounds down always. It rounds down.
Always, yeah.
Oh, quick!
Then-
There's a new thing too, actually. Sorry, go ahead. What was it?
No, I was just saying, even though it's like, if you're setting it to a double, it's
Yeah.
still gonna apply as an integer. Okay.
Because ATOI does integer. ATOI. ATOF would do the double.
Okay.
One quick thing about ATOF is that I am allowed to do this. 45E4. So if I were to print this, it's 45 times 10 to the 4. So I am allowed to do that. Also, a quick note is that if I E4 and then say hi, that doesn't affect it. It stops reading the moment there's a character that doesn't make sense to it. So H doesn't make sense to be part of ATOF. So it just counts 45E4. That's what it reads. If I were to say, 45E6 here, doesn't affect it. It still just reads 45E4 because the moment it sees an H here, it says, well, I don't understand what that is. So it's just going to read this, and that's all it's going to convert.
What if you did high 45E4?
It won't do anything.
Won't do anything. Okay. Like,
I'll
will it
do it,
store
I'll
any
do it.
value or null?
I guess 0.
0. Okay.
So wait, what you were saying about what the int arg get versus the character argv was keeping? Can you just repeat that?
Yeah, so int argc is counting how many arguments you're putting into the main function. And char argv is the actual 2D array that contains all the strings, which are the arguments.
Okay.
Right?
I mean, I think I get it. Yeah, okay.
This value is always 1 because the 0th entry of this is the name of the main file. Always. The name of the main file.
Wait, what is always one? The int?
Int argc is always 1 because it always has 1. There's always one item there. And it's at the 0th entry of this, and the 0th entry is always the name of the main file.
Okay. Okay.
And that's it. That's everything for command line arguments. That's everything for everything. That seems like it's the course. I will quickly edit my notes here because I realized I made a mistake. So let me just do that quickly. I'll say because I just want it to be correct for when if anybody wants to look at it before the test or anything like that.
Do they update on the website?
They do, yeah. So it'll just be the same website. Just go there.
So it's automatic? So
Well, yeah.
How'd you do that?
In Google Drive, it's one Google Drive link, and you can right-click the file in Google Drive, say Manage Versions, and upload a new version. It'll be the same link.
Oh, and the website, did you make it? And then you bought a domain or downloaded a domain?
Oh,
or...
that? Yeah. WordPress. I did it with I bought a domain and made it with WordPress.
So. Damn, Adam. Advanced stuff. Jeez.
More
That's awesome. I love it.
Thank you. Yes, I like it. I think it's a pretty cool website. So, okay, just making final changes here because I kind of forget where I made one more mistake and I can't find it now. It's one of these files. Anyways, but that's all for the content of the course. So if I'm here for any more questions if people have. Otherwise, good luck. I hope everything goes well.
Wait, I think you guys might have done this in the first session because I see this is session 4. Did you guys do the whole IEEE with the mantis and stuff? Because that's one thing I definitely don't remember at all.
We did not do that. We did not do that. No.
Like my professor said that. Not even my professor at the study hall. She was just like, "You guys should remember that because there's gonna be a question like that." So yeah, IEEE is. She said it was gonna be in the test. So yeah, heads up, guys.
Yeah. But yeah, so I'm here for any more questions people have, and just good luck.
Is going over binary conversions even worth it, or is it not enough time? I guess it's only 45 minutes, so.
Yeah.
I mean, you don't have to go over all of it. I'm just saying, you should like kind of remember some of it, right? So just remember how to do the whole IEEE thing. So that's about it.
Yeah.
There's a
Do you
good
think
YouTube for this
Mantis
stuff.
would also be on?
That's a part of the IEEE, right?
Oh, right.
There's the IEEE and there's the two's complement.